So what are the best tools for 3D data processing in 2025? We actually have to see the large scope and see that we have buckets that will help us constitute a toolbox and a skill box. And this is what I prepared for you. Hi, so my name is Dr. Florent and I'm a Research and Development Director, author of the 3D Data Science with Python books, and founder of the 3D Geodata Academy. And in this video, I want to share with you the 9 buckets that I'm going to give to you right now. Let's start with the first one, which is 3D dataset curation. So when we speak about 3D data curation, essentially we mean how can we get hands-on data? And in here, we have the ability to gather data online through various portals. So it depends on your industry. So for a 3D model, you can, for example, go to Sketchfab, and this is where you will find new models. So if I put 3D horse, for example, you see that you have model of horses. You can check that it's downloadable, and then you can check on the license, and also you have specific categories, right? Some of them are paid, some of them are free. You can filter that by if it's free or not. In here, you have the license, and you can put only the free license, for example. That will allow you to download free elements. Whenever you click on something, for example, done by this guy, you see the number of downloads, and you can download the 3D model. This is one of the examples of getting hands-on 3D data. Another possibility is using open topography. And in this space, you can get your hands onto LiDAR data. So if you go onto data catalog, you have the ability then to download LiDAR, but not only LiDAR. You can filter out by source and location or advanced filtering. In this case, if I just want point cloud data and I filter, you see that I can get data on various territories. Another possibility is, as I mentioned, is Open Data Initiative. In French, you have LiDAR HD. And just in here, you can go there and go onto the tiles, move very closely somewhere, take a tile, and you can download or visualize the tile by just clicking in here and start playing with the data. For example, this is already classified, so this can also speed up training your model. And aside from that, you also have a lot of external sources, right? To gather CTGML models, to gather voxel models and entities. Now from external sources, you have some example like Mapillary that allows you to get your hands onto like 360 imagery, for example, but you have OpenStreetMap that allows you to get your hands onto vector data that you can then leverage. Really, it's just a matter of going online and typing the right type of data that you want to source. If you're in the research community, you have a Google Datasets search that allows you to search for specific data. If I were to put MNIST, for example, this is a data set for building object like character recognitions, number recognition. If you were to put S3DIS dataset, you see that you get the dataset that is an online dataset for 3D, like from Matterport, but for 3D indoor environments. This is another way to gather datasets. Now we can move on to our second bucket, which is linked with 3D reconstruction methods and the hardware that goes alongside. 3D reconstruction methods are super key to obtain real-world data that you can leverage for engineering application, for example. And these mainly fall into two main categories. There was a debate for a long time on that: photogrammetry and LiDAR data. What we have in photogrammetry is mostly image-based reconstruction. So whenever your sensor is a camera, this is where I will put photogrammetric reconstruction. And with the LiDAR, it's essentially a laser scanner that will send a pulse and receive back this pulse from any object that it measures, and computing, for example, the time it takes to go to the object and come back, we can define the distance. And on top of that, we have a way to measure the angles, which means that we can generate 3D point clouds with LiDAR and imagery. We also have ways to combine both to have something more exhaustive with data fusion mechanism, but this is usually hybrid tech. Okay, so for photogrammetry, you have various resources online. So this is, for example, one tutorial that I wrote that allows you to reconstruct 3D objects using reality capture, that is free under 1 million in revenue, or Mushroom, that is open source based on Alice Vision. This is also, for example, how I scan the environment that I showcase here with a terrestrial laser scanner, and this is from Leica, a PL case. This is the entry point, and you have much more accurate terrestrial laser scanner. But essentially, I would recommend you to check out this specific article if you want to build from scratch your first 3D models. Now, there is a third way to reconstruct 3D data, and it's generative modeling. With that, I mean that you can leverage AI systems or others to essentially generate data from scratch. This is usually pure inference work, so it's not really measured like we do with LiDAR or photogrammetry. Now, if you are into generative AI, a good one is Trellis. Trellis is by Microsoft, and you can get onto this Hugging Face space and directly leverage example or drag and drop an image, click on generate, and you can download the mesh or the Gaussian splatting. So it's very easy, and it allows you to see how powerful it is now to leverage this kind of architectures without much hassle to generate new stuff. Now, let's move on to the third bucket, which is 3D software for local computations. Okay, so 3D software, I have a lot to say here. This is something that is often overlooked by the development community, but is much to use by people that are a bit afraid to put their hands on to coding skills. So we'll touch on that a bit later. But on 3D software, you have various categories of software that I would like to delineate to make sure that it's very clear for you where you should pick any software depending on your industry. So essentially, here you have 6 main blocks. The first one would be all the 3D reconstruction software. The idea is to go from a set of input that will be your images or your LiDAR scan or your trajectory, and you want to output a 3D point cloud, a 3D mesh, a 3D voxel entity. Then you have point cloud processing software. This is what I really love, because if you saw other videos, you know that you can attach pretty much any 3D data modality and 2D modality and attach that to 3D point cloud, do the bulk of the process there, and go back to your modality. So this is a canonical frame of reference. It is super nice. You have a lot of options as well here. Now, the third possibility is 3D mesh processing software. Here as well, you have a lot of possibilities. Aside from that, we will dive onto voxel processing. Here it's a bit more niche. I will cite 2 main ones, which are Magica Voxel and Minecraft. It's really handy, voxels, because essentially you create this kind of representation that is more lookalike pixel data, and you can handle that in a raster way, but for 3D, so it's very handy. Now after that, we want to move on to creating experience, and this is what I call the category of virtual environments. In here, you have mostly game engine, but you have also other software that allows you to create animation, virtual tool renderings, and this kind of thing. And finally, I will put another category with supporting tools. So any tools, any software that help you automate some part of your process, any software that help you manage your projects, your 3D project, this will fall into this category. So with that, essentially you have a full set of tools at your disposal, which is open in this case, or closed source, and that help you leverage 3D data processing capabilities. Okay, so for the 3D software, I will make a dedicated video on that to make sure that it's not too lengthy. But essentially, on the 3D reconstruction side, I already mentioned you have Mushroom, very easy. On the processing side, you have Cloud Compare, which is this software, and you can download it. On the mesh processing side, you have MeshLab. If I go there, yeah, you have MeshLab, very nice. On the voxel, you have Magica Voxel, which you can find, like, just taking the viewer will be enough. As you can see, you can handle voxel. This is super nice. And for the rest, virtual environment, I would recommend Unreal Engine or Unity to generate like beautiful 3D experiences. And for supporting tool, I like to use task management and project management with my teams. And for additional tools, I will recommend ClickUp if you want to manage projects. This is a super cool tool that allows you to do just that and monitor the evolution and log everything and also create a knowledge base. So this is very handy. That's it for the software at this stage. Okay, let's move on to the fourth bucket, which is computing hardware. Within this category, we have four main stuff that I want to touch on. The first one is, of course, a computer. You will need a decent computer to handle 3D data processing tasks. Usually, except if you are part of a large company where you have already a cluster established and things like this, usually what I recommend is really getting your hands onto a nice piece of equipment, which is your computer, because you will need to do a lot of rendering, real-time handling your data. And for this, you will need a good CPU, a good GPU, large storage capacity, and a lot of RAM, especially for 3D reconstruction, which means that this should be maybe an important investment bucket. And just to give you an element of comparison, my computer that is now 1 year old, right? I bought it for around 1,800 euros, and I know that I will be happy with it for at least the next 5 years. So this is just to situate a bit with the current context, how much money you need to invest in to get a nice piece of equipment. Of course, the most expensive part is the GPU, right? So here you want to aim for something like a 3070 plus, 4070 plus, 5070 plus from NVIDIA with CUDA. And on the CPU aspect, you want to have a very high power CPU like an i9 or a Ryzen 9. On the storage capacity side, really make sure that you have at least a 2 terabyte SSD drive. This is very important. And aside from that, a lot of RAM. So at minimum 16 gigabytes of RAM. With a computer with their specs, you will be very good to go. Now, I also want to highlight another component, the storage. I already said 2 terabyte SSD is very good. But you have to know that 3D data is very heavy. So it's good if you have like a buffer drive. It could be an HDD drive where you store stuff that you don't need to handle very often, which could be 5 terabyte HDD drive. This is not super expensive. You can find for $100 5 terabyte drive. This should do the trick. But you can also leverage cloud solutions, right? Just make sure that you put in place the security layer that allows you to work easily with the data, but in case of a problem, to get back your data safely. Now, on the subject of peripherals, I highly recommend one thing, which is having 2 screens. Why is that? Because usually you will, especially with 3D data processing, I will touch on that later, you'll have one screen that is super dedicated to the 3D aspect of things, and one other screen where you monitor the training time of your machine learning model, the rendering times of your rendering engine, or your code that is on the right and you execute on the main screen, the main component. So this is what I highly recommend. Also, if you are in an industry where you need to actually use AutoCAD or DAO tools and software, this is very handy also to have, for example, AutoCAD here and the 3D visualization on the second screen. I want to touch a bit on this category upon cloud solutions. So this is very handy, especially if you do not want to invest early on onto a large piece of equipment that I mentioned before. You have the ability to leverage super nice infrastructure with GPU, a very powerful GPU, very powerful CPU, a lot of space and things like this. Honestly, all cases are really making sense whenever you want to put out a product to scale, right? Where you will maybe leverage AWS from Amazon or Google or Azure from Microsoft. Nevertheless, that has a cost and usually it's hefty. I've seen that. It's always best to start locally, and when you have really something that you need to scale, there is no cutting through that. Scaling is very, very handy with cloud solution. But before there, I would really encourage you to just stay local with your machine. It's also eco-friendly, much better than you need cloud solution. So this will be my recommendation. Nice, we can move now on to the fifth bucket, which is coding. You have a lot of possibilities, and I want to touch here on 5 main elements that relate to coding. The first one is language, picking out a language. In 2025, I highly recommend, if you are new, to pick Python. This will allow you to do everything you want to do. If you are already well versed into Python, and you want to have something more modern, Rust is the way to go. I really like this language. It has a high security layer, but it's also a bit steeper. And you cannot really do with the same level of abstraction as in Python. There are stuff that you can do in Python that you will not be able to do in Rust, but it's much more efficient. And the third one will be C++ or Java, depending on your preference. These are the languages like performance-oriented that I will recommend, especially if you're in the gaming industry and computer graphics. This is something that is very relevant. Aside from that, you pick the language, you will need to manage your environments. And let me develop things with Python, because I believe this is what 90% of you will be greatly benefiting from. And you need to manage your environments to avoid all the headache around coding, and you can focus on only creating. Like, you have an idea, you just create your algorithm, you press play, it works. So for that, you need an environment that will take care of isolating the version of your various libraries that you use, and they will take care of specific conflicts essentially, and isolate in a way you can replicate experiment. You can extend that with Docker that allows you to share whatever you built, but I think at the first stage, Anaconda will be great to manage your environments, and Docker is not exactly doing the same at all functions. Now, I talked about the language, Python, and the environment management, Anaconda. Then, after that, you have the chance to leverage existing libraries, so you don't have to code everything from scratch. And as part of Python libraries, I think what you need to be able to handle early on is NumPy, Panda, Matplotlib, and for 3D, Open3D, and for machine learning, PyTorch and scikit-learn. And with that, you are pretty much free to do a lot of stuff with only Python. Now, I talked about it a bit. Algorithm. This is fundamental before moving on to AI, what we call AI, machine learning, deep learning. These are algorithms that we design. So this is only a fraction of what you will use, and especially in production, usually the first stage is leveraging your knowledge about 3D algorithms and algorithm that performs well for 3D datasets. If that fails, you move on to classical 3D machine learning, like random forest, support vector machine, and bootstrap and mechanism that allows you to leverage features that you engineer. And if that fails, you move on to 3D deep learning. But note that every time you move up in this line, you lose expert knowledge control on your algorithm, and it's harder to maintain, and you are putting the focus much more on the quality and the quantity of your labeled data or data itself that you want to use to build this kind of machine learning, deep learning model. Finally, you have to touch onto life cycle of your code and data management. You need to know exactly what is your data lifecycle and what is your project and code lifecycle of your product. You need to know when you push out something to the ML engine, when you push out something to the algorithm engine. This kind of elements need to be locked on early on. And you will be very happy if you can get into this kind of condition. Okay, after coding, let's move on to the sixth bucket, which is knowledge and ideas. Right, this may be my favorite part, knowledge and ideas. This is actually the 3D core of everything. If you have knowledge, you can generate new ideas and you can create and build stuff. And this is where I encourage you to check out the 3D Geodata Academy and specifically investigate 4 main tracks for 3D data processing. And here they are. The first track is everything linked with 3D reconstruction. And here you can dive into the Reconstructor OS or Creator OS. The idea is to take you from scratch and allow you to build a 3D reconstruction engine, and you can extract from that 3D asset that you can sell on the store, virtual tours that you can create, or any sort of renderings that you want to do, and immersive experience. So in the collector park, which is now the Creator OS, you have everything linked with 3D Python, 3D photogrammetry, and 3D point cloud processing, for example. And you also have a bit on 3D object. The second bucket is 3D Segmentor OS, and here is really if you are an engineer and you want to automate a full pipeline from scratch with Python. At the end of this track, you are able to create an app that will ingest any type of data and spit out any type of deliverable. This could be a BIM element, this could be drawing, this could be just a 3D mesh, this could be a Gaussian splatting. This is part of this specific course line. What is super key is, of course, all the algorithm that you need to use and how you can tie that down all together. So this is 3D Segmenter OS. On the 3D Segmenter OS, you can create 3D apps, but not standard one. It's really advanced one that you can monetize by combining 3D, Python, and AI. This is an example that you can see here. You have a point cloud, you drag and drop it into this kind of GUI that you create from scratch with this course. You have all the code, all the samples, all the data is given, and you get the results of the automated segmentation, for example. Aside from that, so you have 3D reconstruction, you then know data and algorithm. The third side is 3D Intelligence OS, and it is where here you will find all the deep learning architecture, all the machine learning advanced mechanism for 3D datasets, and also how do you consider semantics and how do you augment your datasets, right? So for this one, you already need to know at least 3D Segment OS, because else it will be very steep. At this stage, I assume that you know Python. And finally, you have the 3D deep learning course. This is the most advanced one. This is 3D Intelligence OS. And as you can see, I did that with my good friend and partner, Jean-Jacques Ponciano, which has a PhD in AI, to make sure that the code that we push works, because we had it with the nightmare of GitHub's repositories that never works, need special configuration here. For example, one architecture, we implemented it for 6 months straight, where Jean-Jacques spent 6 months full-time to re-engineer all the code of Superpoint Transformer for 3D datasets. So this is really for power advanced users that you have here. We are ready to move on to the 7th bucket, which is AI tools. Fantastic. All right, so in this bucket, I have 7 main elements that I want to touch on. AI tools. What do you have inside? So the first one is everything related with code AI tools. So you have a capacity to inject AI to help you develop new apps using code, but coding in a better way, in a smarter way, in a more efficient way. For example, you have Cursor AI, or if you use Google Colab, you will see that you can get an error after running something and immediately ask the AI that is embedded in the system, why do I have an error? Can you fix it? And it will fix it by getting the context of what you're writing and giving a solution. This really can cut down a lot of time, especially in the early rounds and early stages. So one of what I would like to show you, it's Cursor. If you want to have and test an AI code editor, this is really, really nice. I would recommend that you check out what you can get from it. As you can see, you can directly do a review request and have something that is very natural. Like if you are really new to coding, this is very handy. If you would just want to use online solution, you just go to Claude and you can ask some very easy stuff, like, okay, creating a Python script to convert ROS to LAS. This is an example. Projecting 3D point cloud to 2D ortho image. This was to showcase some specific student how they can leverage that whenever they build the core knowledge. And it's very easy then to accelerate the creation of new solution with Python. The second one is media generators. In here, you are maybe already aware of that, but you have a capacity to generate with AI images, text, and a lot of various outputs, even 3D models, using generative AI or other mechanisms. After that, you have something that I called AI coworkers. And in that categories, essentially, it's a possibility to leverage AI to assume some kind of role, like your virtual assistant, like your content manager, like your pipeline director, and all of these roles, if you specify really clearly with prompts and meta prompting mechanism, what you want your AI system to do, it will be able to execute. At the moment I'm talking, it's not human level, but things are going really quickly. So already jumping onto the wagon will make it much easier when it's fully bulletproof. Right, after that, I have what I call knowledge gateways. And this is building some kind of better understanding based on existing knowledge base. What do I mean here? For example, if you go through one of my course line on the 3D Geodata Academy, you will have something that is nowhere found on the internet. and that AI system don't have access to. Nevertheless, you can extract some kind of component from it if you did not understand and push that through a AI system for knowledge recovery and ask stuff to deepen your understanding of a specific topic. For example, it could be, all right, so Florent is speaking here about 3D deep learning architecture and attention layers. I don't really fully grasp what he means about attention for 3D dataset and why it's a specificity rather than convolutions, for example. And doing that, the AI will be able to leverage like common knowledge or like mid-level engineer knowledge around this kind of topics and help you decipher something that was maybe not at the level that you wanted to have it. So I mentioned notebook LM, right? Let me just show you something. So if I click on try it, you see that I have, for example, this where I have all my book chapters that I wrote, -1, and you can immediately ask specific steps. So what are the strengths and limitation of various clustering methods? And it will give me an answer that will leverage the knowledge in all of the chapters to make something sound out of it. As you can see, it only uses what I wrote to create new knowledge. So this is why I really like it, because you have a clear hand onto where he constructs his knowledge from. And this is something that I wrote, and that is out from 15 years of doing R&D in the space, and was the biggest project, so I know this is reliable, for example. Aside from that, you have what I would call communication assistance. So this is a way to leverage AI to better communicate. And this can be for creating posts for LinkedIn, this can be for creating a description for YouTube. So that's kind of maybe a low impact, high time tasks that allows me, in my context, to focus more into laying out a strategic plan for a company or helping a team deliver on a specific new application for 3D. Right. Aside from that, you have everything that is in-app AI tools, and new things are popping up every day, but essentially you now have the capacity to use AI in a specific tool. Like it could be using Copilot in Word, PowerPoint, and things like this, Gemini in your docs. It can be using ChatGPT to generate tasks and play on your various apps. It could be Anthropic and Claude AI to like ask him to open the window, open a browser, execute that, send an email. This is something that is now feasible, and it's exciting. It's also very dangerous, so be careful about what you're doing if you allow such system to have a hand onto various applications. And finally, you have AI-based workflow, which is tying down everything and automating fully a pipeline, but always remember that it's best to build and test before automation. Right, so that was a long bucket, but I think it's really worth it, especially in 2025. Beautiful, we touch onto the 8th bucket, which holds writing and research tools. Right, writing and research tools, this is a bit more niche, but if you are like me, you love really understanding deeply and not the surface level concept and new technologies to create new innovation. Which means that one of the ways to do that I found really beneficial is by trying to share whichever you learned and trying to teach that to others with your own words. And these go into the track of writing and also research. If you really are in academia, doing your PhD, or you finish that and you are just a research engineer, you now can do research in a wildly different way than we did 5 years ago. You have tools that help you better curate information, better create your state of the art, make more exhaustive industry and academia look out for what is existing. So these kind of things are now at your fingertips and you can leverage that. The same goes for if you are writing tutorials, writing a book, you need to source element. Of course, it's very important to first acknowledge the use of these tools and also make sure that everything that the AI gives you is tested and relevant, because you have a lot of hallucination that happens. I, for example, tried to test it whenever I started writing my 3D Python book. I immediately stopped because it was really too random, and because the book, I wanted to have it deep and really on things that are not existing, the reference that he was giving me were either nonsense or he was citing me through various articles, so it was really not useful. And finally, the 9 optional bucket, which is communication tools. Right, and the final bucket, it's a bit aside, right? But it's everything linked with communication tools. This is touching a bit with writing and research, but here I think it's very important to have a way to communicate your findings and communicate your creations, which mean having a video editor software. This is very useful. You have free ones and you have other ones that are paid. This is up to you which one you want to choose. Newsletter. If you can create some kind of newsletter to inform people that believe in what you're doing, I think this is also very good. And then social media. This is today essential. This is not my favorite part, but it's important to be there because you reach out to people with a certain perspective. And finally, everything about data and product sharing. So whenever you want to push out code and push out data, this is where you want to go. So as you have seen in here, we have these 9 buckets that are super useful for any development and 3D creation that you are going to do. These are the 9 that we see here: 3D dataset curation method, 3D reconstruction method, the 3D software, computing hardware, coding, knowledge and ideas, AI tools, writing, research, and communication tools. With that, you are fully equipped to do 3D data processing in the best possible condition. All right, so this may be the most fundamental aspect that is essential for 3D data processing. If within this bucket there is something that you are particularly excited about, please share that in the comments. The second thing is, if you want me to deep dive in one of the tools, one of the datasets, one of the methods, one of the AI tools, please share that also in the comments below. This is how I constitute my list of new tutorials to come. See you in the next video. Bye bye.